So this is G481 homework booklet question 17. Starts off straightforwardly enough, asking what form is energy stored when a metal wire is extended by a force. Simply, it's elastic potential. The word potential on its own isn't useful because it doesn't distinguish it from gravitational potential energy. Elastic potential energy. They also accepted strain. Moving on then, we're given some data about a piece of wire and we're asked to calculate the strain in the wire. The strain is 2.92 times 10 to the minus 4. What are we doing? Simply dividing the extension, 0.35 millimeters, there's times 10 to the minus 3 for the millimeters, by the original length, 1.2 meters. Only one mark, straightforward use of a formula and shoving the numbers straight in. Next we're asked to calculate the tension in the wire. The tension isn't nearly as straightforward. Tension obviously is a force, so ultimately it's force I'm trying to get at. And I haven't got any information that really helps me with that. So if I look back at the question, what have I got? I've got that there's a weight, but it's not telling me what the mass is, so I can't calculate the force that way. I have just worked out a strain, and I've got a Young modulus. I think very much in kind of one lump in my head, if you like, one unit in my head, the idea of stress, strain and Young modulus. So if I've got the Young modulus and I've just calculated the strain, I can get the stress. Now, kind of from the other direction, if I'm after a force and I've got a cross-sectional area, that also makes me think about stress. So I've got that stress as my midpoint. So this is going to be a two-stage answer. First of all, I'm going to use the relationship between the Young modulus, the stress and the strain. The Young modulus I was given, the strain I've calculated. That allows me to calculate the stress. Young modulus is stress over strain. Rearrange that. Stress will be the Young modulus times the strain. And there's the stress, 5.55 times 10 to the 7. Once I've got the stress, I can use stress as force over area. I've got the stress, I want to know the force, I've got the area, rearrange that, and I get to the answer 7.8 newtons. Moving on then to the next part of the question, part C. Really completely separate, almost a little bit of comprehension material, and we're given information then about carbon nanotubes. It says there is great excitement at the moment. To be fair, I think this was from 2009, about around then, and it asks some questions about that. Now really there are two ways that sort of these sections where we've got a chunk of information, there are two ways these questions can go. They can either ask about what's said, or it can just pick up on little details in there. So it says the diameter of a CNT is a few nanometers. It's just picking up the detail here. What is a nanometer in meters? There we go, 10 to the minus 9. Job done. Asked to explain what is meant by plastic deformation. Again, definition that's on the definition card. Plastic deformation means that the material does not return to its original dimensions when the force is removed. How many times stronger are CNTs than high carbon steel? You've got to know for this that when we're talking about strength, what we're talking about is ultimate tensile strength. Okay, so how many times stronger? I've got the 60, I've got the 1.2, both in gigapascals. So here's the sum, 60 times 10 to the minus 9 divided by the 1.2 times 10 to the minus 9. That gives me 50 times stronger. And then finally it asked me to state two advantages of making bicycle frame using CNT technology rather than high carbon steel. And if we go back to the text, while I was reading that, it tells me that it's one of the strongest and stiffest materials known. And it also tells us that it's got a very low density. So the low density is going to tell us that the bike's got a low mass. Low mass has got two advantages. Low mass means it's easier to accelerate, think F equals ma. Also means it's got a lower weight, think W equals mg. If it's got a lower weight, that's going to make it easier to get up hills. So the lower mass is one big advantage, and then obviously the fact that it's stronger, simply it's going to be more difficult to break it, would be the other advantage. Interestingly, I got a number of people there, instead of using the word stronger, using the word durable. Durable is a slightly vaguer word, to be honest, perhaps about how long it would last, or how crack resistant it would be. It can mean a number of different things. It doesn't mean the same as strength. The property that we've got information on is strength from the ultimate tensile strength, and so we need to be careful we're in there using the precise physics words. So that's G481 homework booklet question 17.